So we move to the second one, elongation of anagen by red LED, possibly through paracrine mediated for dermal papilla. Professor Inui.
Thank you, Mr. Chairman. So today I'd like to talk about elongation of anagen by red LED and through possibly through the paracrine factor of the papilla cell. So already some paper about LED or LLT effect on the hair growth were presented in this meeting. And so I would like to mention a brief introduction about LED or LLT effect. So initially the NASA in US try to develop LED light to grow some kind of plant. So when we go outside from Earth in the planet or in the space, so we don't have sunlight. So therefore, instead of the sunlight, so they think about using LED light to grow plant. And but later, so in area of medicine. So LED has been investigated in terms of wound healing. So LED is effective for the wound healing. So LED can enhance collagen production and proliferation of fibroblasts. So this report is in 27 or 5. So later, also on the other hand, LLD, low-level laser therapy, can induce hair growth in androgenic alopecia. Actually, the light of LED and LLD is very similar, so therefore it's very easy to consider the LED effect on the hair growth also is a. So then we try to investigate the potential of LED as a new therapeutic strategy for the hair loss disease. So actually, when we start to investigate the LED light, so we did have three kinds of LEDs, so the blue and green and red. So, but actually, the red light can penetrate most deeply into the skin. So therefore, we focus on the red light. So actually, we study about wound healing by LED, and also other than so green light also effective for induce early wound healing. But so in here research, so we focus on the red light. So at the beginning, we tried to investigate dead LED effect on anagen induction in the mouse. So we utilized B6 mice and 7 weeks old. So as you know well, so the dose of this mice have telogen hair follicle. And then we shaved here, and then after that, so we start to irradiate LED on the dorsal of mice. So the wavelength of LED light is 38 nanometer, and half bandwidth is only 10 nanometer. And the energy is 1.0 joule per centimeter square. And actually, we irradiated 3 times a week of this red LED. So this slide shows you the hair growth after the LED irradiation on the dorsal of the mice. So day 1, of course, so there's no difference. So this one the control sham treatment mice, and also this one the LED treated mice. So, but later, so at day 18, so you can see the hair growth on the LED. So you can see the black area on the dorsal of mice. But in the control group, so only some black spot you can see, but so there is a significant difference in terms of hair growth. You can compare this one. And 4 days later, so the hair growth really, so the shown here, so the hair growth is much more than these days. But in control mice, only show little the hair growth. So at this day, so we sacrifice the mice, and so this picture shows on the skin from the under area, and so the LED light treated mice. Those skin shows this kind of a black color, so indicating anagen induction. But on the other hand, this control mice show only one spot on the black spot. So almost all hair follicle is intact. So then, from the picture of the mice, we calculate the hair growth area percentage here. And until around 10 days, so there's no significant effect, LED. There's no significant difference. But at day 18, so as I showed on the last slide, so there's a significant difference between the two groups. And also at day 22, so 22nd, so you can see the difference, this one and this one. So finally, the sham treatment mice so catch up to the LED treated mice, but at least this period, you can see the significant difference in terms of the hair growth on the dorsal of the mice. So therefore, we can say the red LED can induce anagen, early anagen induction here. But basically, in case of AZA, androgen alopecia, so not androgen induction, so but early catagen induction is a problem. So therefore, so we think about so investigating the LED effect on the catagen induction. So then we use the same mice, and the B6 mice and 7 weeks old. And then we perform the hair plucking to induce an anagen. So actually, so every day after, from the day, 12th day after the hair plucking, we start the irradiated LED with length of 38 nanometer, but it's the same as the last experiment. And the energy is a little bit increased, 2.0 joule per centimeter square. So I show you the timetable again. So the hair plucking is 0, and so this should be the induced anagen. So, but normally, so the from day 17 to day 19, the catagen telogen induction should happen. But if we irradiated the LED from here between day 12, so some kind of effect should be happen on this catagen induction. We hypothesis that kind of effect. So then this slide show you the LED treated mice and control mice, sham treated mice. Those are. Probably you can see some kind of a color difference. So LED mice should have more blacker skin on those, but it's very difficult to only by watching the skin. So what is the difference of the hair cycle stage or hair follicles? So we need a histology of a hair follicle to make a difference of these two mice. So after this one is the histology of dorsal skin of LED treated mice and control shunt treatment mice. So you can see the relatively bigger or larger hair follicle remain in the LED treatment mice. But in control mice, so the hair follicle already into the cartilage or telogen, you can see. So we need the parameter or data to decide whether it's significant or not. So then we use the so-called histology scoring for the hair follicle in terms of hair sampling. And anagen should be the 0, and early catagen 1, middle catagen 2, and late catagen and telogen should be 3. And then we check the shape of the hair follicle one by one, and so calculate the mean of this histology score. Then in control, the scores are here, so already near to the red catagen of the telogen. But in LED treatment mice shows only 1.3 or around there. So there is a significant difference between the control of LED. So the LED mass score is lower, so it means they still have early catagen or anagen, so they delay in catagen induction compared to the control mice. So therefore, we found that red LED can delay the catagen induction. So resultantly is also anagen elongation. So next we think about what is the mediator of from dermal papillus. So we changed the human dermal papillus culture and so irradiate red LED again and perform the RT-PCR. So we checked the various kind of mediator, and so we found that HGF, leptin, and VEGF is upregulated. You can compare this line and this line. And also the TNF alpha is decreased. So this is a kind of a reasonable because this factor can the distinct function on the hair growth. So HGF, the anagen induction, the maintenance, and so the leptin can induce anagen. So data from our lab. So the VEGF is well known. So the genetic factor in hair follicle and also induced minoxidil from the papillus. On the other hand, TNF alpha is an anagen suppressor catagen inducer. So then we check the protein level production of these factors. So same thing we perform. This data is ELISA using a condition media of the dermal papilla, and so LED can induce and also the leptin concentration also increase. The VEGF can be induced from here to here by the leptin. But in case of TNF alpha, so we couldn't get a significant difference between the two groups. So therefore, at least we can conclude positive mediators such as VEGF, HGF, leptin, and dermal papilla can play some role in that LED in this to hair growth stimulation. So that is summary. So the LED induced anagen from telogen was visit mass. The LED delayed catagen induction from anagen and resulting in elongation of anagen. That LED can induce a positive mediator such as VEGF, HGF, leptin from human dermal papillus. That's all I have today. Thank you for attention.
Thank you, Professor Inui. So I guess some comments or questions?
Thank you for your great talk. About your LED irradiation, you found that the catagen delayed.
Yeah.
But actually, turns out it's anagen elongate, right? Did you find that the hair longer?
Yeah, actually we didn't so the major such kind of, are you in the next?
Yeah, because you elongate anagen. They're supposed to have longer hair. The
Yeah,
cut hair is a bit
but
longer.
we didn't check it. We didn't check it. So just so we found out the two effects. So anagen induction and catechin. So delay. So therefore, so just theoretically, so it should be.
Just delay the apoptosis.
Yeah.
Because sometimes the waxing or a plucking will alter the regeneration time because it depends on how you wax it. Is that possible that because the method you do it, so that's why it seems like it's longer staying in the energy period, or it initiate later into the energy?
Okay, so we try it. So thank you for the suggestion.
Any other question? So, Professor Inui, so I'd like to give one question.
Yep.
So, if there's laser therapy using the 638, the same wavelengths,
Yeah.
and then so you can provide 638 nanometer with a very, very narrow LED.
Yeah.
They can work the very similar way.
Yeah, I think so. But so actually, there is some 5 reports about randomized controls prior already, and so LED and or LED can use hair growth in elderly patients. So, but we don't have the device. The data from the device contains only LED. We don't have still that kind of data. I think we should do that kind of a trial.
Okay, thank you.
Thank you.
So move to the third one.